It's Monday morning. You've overslept and you're rushing to get ready for work. While styling your hair, you thought you'd put on some toast for easy breakfast. But suddenly, you get that awful feeling and you smell the smoke. The toast has burned, and it's because your brother keeps messing with the settings. But you tell yourself that it's fine and that you'll miss breakfast because there's no time and you've got to go to work. But why hasn't this problem been solved? I mean, over the years, we've seen the fridge, oven, dishwasher all evolve to become standalone smart devices. So why not the toaster? That's when our client, Ben, came in and approached Marc, the DMMS subject coordinator. Ben wanted to find a solution that wouldn't cost hundreds of dollars. So we, Group 3, took on the challenge to solve this age-old problem. Stick around to see how we made this happen. The design process began with identifying the scope and requirements for the project. Realistically, we quickly came to terms with the fact that we couldn't create a whole new toaster. However, our client was particularly interested in advancements through sensor technology rather than the entire toaster itself. So we spoke further with the UTS's lab staff and aligned new goals with high safety standards to create a prototype without actually modifying a toaster. Using the adaptive problem-solving procedure for product development model, we iterated across multiple methods to achieve the requirements for the smart toaster. We then compared different methods and techniques, and we dialed it down to a select few until we were satisfied and ready to begin the initial prototyping. In our initial prototyping, we trialed and put together all sorts of electronics and 3D prints. Some ideas, they showed potential, but some, not so much. Until we struck gold. Through measuring both the temperature and weight change during operation, we could find a powerful validation method. With this method, there was no need to create a new toaster or modify one at all, as instead we could create an extension that in theory can be paired and placed with any toaster. So we got to work. Entering the second stage of prototyping, we created two PCBs to separate the sensing and control methods. The first one being a control board, specifically designed for user interaction and live weight reading. The next board was a sensor array board, combining the temperature, motion, and color sensors. The two communicated via flat cable to create a modular, multifunctional electronics assembly. Now it was time to iterate with Alim's test bench system and Nikhil's toast holder. I modified the CAD to create a complete assembly with the provided click-on lid and spacing for the electronics. Everything clicked right into place to make an aesthetic yet functional prototype. The toaster slipped right in, we finished the software, and then we could set the power on.
As a future expansion, we designed a smart plug that worked with our smart toaster controller. This expansion lets us safely integrate power control without tampering with the toaster. By adding this smart switch, the main controller can manage the toaster's power state, giving us precise control and allowing the system to automatically shut down the toaster once the desired toast doneness is reached.